So, out with the old. Let's touch on some of the old myths that have been debunked that neuroscience was really built on for years and years. Okay? Number one, deterioration of the brain. We are led to believe that the brain is nothing but a withering ball of tissue that plaques up and gels up and ends up going bad before we die, and we end up being crazy. And I may be making a little bit of a joke about that, but literally, this is how we are looking at the brain in science right now. Dementia is running rampant. Our elderly population they're not being taken care of. The system itself is kind of just allowing the problem to continue to perpetuate itself. So we used to believe that for years that the brain failed randomly, that just by chance if someone got dementia or Alzheimer's or something like that, it was just a random thing. There's really nothing that could have been done about it. How many people believe that things are just written in the stars when it comes to their health? Okay, so you've been listening. For the vast majority of us, we are writing our health our entire life. We are coding our DNA every day. And we have the opportunity, if we have a gene that is susceptible to disease, we have the opportunity through our behaviors and through our lifestyle to make sure that that gene does not produce disease in our body. So we used to think that deterioration in the brain was just random. Second, learning is difficult due to a fixed brain. Everyone remember the thought process that have you ever heard that the brain stopped growing and developing by about the age of 20? Yeah, we used to believe that. Not the case. So it was believed that at a certain point in life, which was late 20s or early 30s, that the brain was fixed and unable to change its connections and pathways. Can't teach an old dog new tricks would be the saying that would most likely relate to that old myth. And then the last myth that I want to touch base on that's important for this conversation is that once brain cells die, they're gone. Now, this doesn't encourage killing them off on purpose, okay? But it's important for you to realize that this is not the truth. And I'll make sure that you know why it's important as we go on. So another belief has been that once you lose brain cells, you are unable to replace them. All right, so let's talk about the really important truths that have overshadowed those myths now. And it's very, very important that you pay attention here, because the most important stuff that's coming in this lesson, you need to be able to at least grab onto these new principles, because I'm going to reference back to them. Okay? So first and foremost, neurogenesis. The growth of new neurons to replace damaged ones. That's what neurogenesis is. Oh, so the growth of neurons. Well, we were told that once the brain got to a certain age that there was no changing. We were told that once we lost a neuron, that it was gone forever. Well, through the principle of neurogenesis, we found out that's not true. So as you see, this comes from the Dictionary of Psychology out of Oxford. And basically, so throughout most of the 20th century, neuroscience believed that this regenerative capacity was absent from the central nervous system. Okay? And that it only occurred in the peripheral nervous system. So basically what they thought was the only nerves that could be regenerated, or the only neuron cells that could be regenerated, were in your peripheral nervous system. Was basically your central nervous system is your brain and spinal cord, and your peripheral nervous system is the nerves that runs throughout your limbs and abdomen and all that. Does that make sense? So they thought that the only thing that was regenerating was the ones in the periphery. But it was discovered shortly before the end of the century that neural stem cells in the ventricles and hippocampus of the brain divide and proliferate, and that some of them mitigate to other areas of the brain, such as the olfactory bulbs, to form new neurons. This was an extremely exciting understanding especially in the clinical world, because it had major implications in turning around neurodegenerative disease. Meaning that even if someone had lost a lot of brain cells and the turnover of their cells in their brain had slowed down, that it was possible to kick that process of neurogenesis up, to upregulate it. This is very, very exciting. All right? So it's very, very important that you realize what neurogenesis is. It is the production, the reproduction and production of new neurons to replace damaged neurons. Number 2, neuroplasticity. This is the truth that trumped the old dogs learning new tricks not being possible myth. Okay? So neuroplasticity or neural plasticity is the ability of the brain to develop new neurons and or new synapses in response to stimulation and learning. So recent research shows that the brain retains its flexibility or plasticity throughout life, and more or less depending on the person's state of health, etc. So this is a really important sentence here. Recent research shows that the brain retains its plasticity throughout life. The brain can learn throughout life. Plastic or plasticity means flexible. More or less, depending on the person's state of health. Well, hold on now. Wait just one second. This just said that your brain's flexibility and ability to adapt, change, and improve in its environment actually has something to do with your lifestyle. When is the last time you heard that on a depression medications commercial? We aren't being told anything about this in the public. You have the control over how flexible, how powerful, and how efficient your brain is throughout life and throughout aging, through the process of neuroplasticity. This was one of the most exciting findings in neuroscience in the past century, without a doubt. So, following injury to the brain, neuroplasticity may allow uninjured areas to take over the processes previously carried out by the injured areas. Do you understand what that said? Areas that are injured in an accident that could no longer take over their functions can be replaced because of neuroplasticity, because your mind is flexible. It will find a way to send the message through the synapses in a different part of the brain, even when that part of the brain was not doing the function in the area that was damaged. Isn't that fascinating? Neuroplasticity is a very, very exciting find. The third is the understanding of neuropeptides and their function. Okay? Stick with me here. I know it's hard for you to understand how this is going to connect, but it is important. Okay? So neuropeptides are compounds consisting of 2 or more amino acids. Hey, we've heard about amino acids, haven't we? Where did we hear about amino acids? Lesson 2 was our first introduction to protein, wasn't it? Where we learned about how our body has 150,000 different amino acids in it, and how there's essential amino acids that need to be in our diet that our body cannot make on its own. So now you're finding out that function of the brain is also very, very influenced by amino acids as well. So they are 2 or more amino acids chained together by what's called a peptide. Okay? They've been described as chemical messengers that act like floating brains, communicating messages with cells all over the body. So if you think of little messengers that run throughout the body and tell the cells what's going up in your forebrain, what's going on, that's what neuropeptides are. So you know how I said Jake sits here in the front brain, and this is where I think, and this is where my personality and my emotions are? What neuropeptides do is they listen to my thoughts, and then they run down to the cells in the various parts of my body and tell my cells what I'm thinking. That's literally what neuropeptides do. Isn't that amazing? The neat thing about it is you actually have a neuropeptide blend of chemicals for every thought you have. When you have happy thoughts, there is a different blend of neuropeptides that shower your body and tell your cells that you're happy. There's also the blend for when you're not. And this is how we're going to talk about how stress can be absolutely devastating to the body's health. All right? So the neuropeptides are released by the neurons in the brain, by the brain cells themselves, as intercellular messengers. This is how all the cells communicate to each other. Some neuropeptides function as neurotransmitters, and others function as hormones. So some have electrical capacity, and some have more hormone and biochemical capacity. Isn't that fascinating? Kind of hard to grasp, isn't it? Even studying it and reading it over and over and over again, it's amazing the complexity of it. So they do just about everything. They can either be pro-inflammatory, they can cause inflammation, or they can be anti-inflammatory. They control our mood, energy levels, pain and pleasure reception, body weight, the ability to solve problems. Anyone here, like the ability to solve problems more efficiently? To think more efficiently? This was one of the things that got me so interested in this, because I've always been fascinated in how to increase my brain function. To be able to work through a process to increase my brain's ability to process information. One of the most recent things that I did was I went through a speed reading course. Has anyone here ever done speed reading before? In the beginning, it's one of the most frustrating things you'll ever do, because you literally have to force yourself through the lines of these pages, and you can't pick up the words to begin with. After you've pushed through these lines, you literally can only think of maybe a word or two that popped out to you, and you apparently read a page. But after you do it for a month or two, eventually what starts to happen is you get through a page, and all of a sudden you got the page. You actually comprehend what is on the page, because you exercised your brain's ability to begin to think more efficiently, to pick up information and process it faster. Because reading a book, your subconscious reads it immediately. Because when you look at a page, even though you're not focused on the entire page, you may be only consciously processing a word at a time, but your subconscious, all of the waves, all of the words are visible in your line of sight, correct? Your subconscious read the page already. You just haven't been able to consciously process it yet. And that's the concept that speed reading actually is built on, is that you are consciously trying to catch up with your subconscious because you've already taken in the information. You're just trying to now realize it and process it consciously that fast. So it's absolutely fascinating. This is also where you form memories. How many people have tried to make an excuse about your age and not remembering things lately? Doesn't have to happen that way. And they also regulate our immune system. So wait, would this be safe to say that how you think regulates your immune function as well? Mm-hmm. Starting to get a little bit more tied in, isn't it? So a new paradigm in how we think about our brain. These principles change the paradigm of how we've thought about psychological health and aging processes of the brain for the good. Okay? So the last three things that we talked about, neurogenesis, neuroplasticity, and the understanding of how neuropeptides function, have all changed the landscape of how we have understood the brain in the past. The interesting thing is the treatment process hasn't caught up, at least not in Western medicine. Psychology has not caught up with these amazing findings of the brain. They still treat people as if they're diseased, depressed. There's no hope for them, basically, that they're basically a chemical mess. You'll find that that's not true as well. With these principles in action, with what we've just learned, the only way that we can experience cognitive decline or neurological disease is through lifestyle factors, such as nutrition, exercise, stress, and other environmental exposures, not defective genes. Do I need to read that again, or do we got it? You got that? Good. Lifestyle is the cause for the neurological disorders and the dysfunction that we have going on right now. And lifestyle will be the cure as well. Whatever causes it can cure it. The same thing. So the biology of belief, Dr. Bruce Lipton. I have had the fortunate ability to meet this man, to speak with him, to go to his conferences. And what he has pioneered in the understanding of the cell membrane, as well as the understanding of how the cell membrane takes response from your thoughts